Okay, let's dive in. We've got a special report here that's, well, pretty staggering.
It really is. It lays out this single enormous atmospheric pattern.
Right, set to dominate Europe and Western Russia between November 5th and the 14th, 2025.
Yeah, big one.
And our mission today really is to figure out how this one huge atmospheric engine,
This dipole system, they call it.
exactly, this dipole, how it's driving three completely different, geographically separate and potentially really dangerous weather extremes all at the same time.
And engine is definitely the right word. We're talking about a very high amplitude structure,
High amplitude.
meaning, unusually strong. Opposite pressure systems, a powerful high pressure area, a powerful low sitting right next to each other.
Like a giant pump in the atmosphere.
That's a great way to put it. A massive pump, super efficient at shunting air and moisture across the whole continent.
And this connects to the bigger picture, right? These aren't just random storms.
Not at all. I mean, Europe's confirmed as the fastest warming continent.
We know that.
And these kinds of extremes, the heavy rain, these compound hazards we'll talk about, they fit exactly with what the IPCC projects. The intensification of the water cycle because of climate change.
Okay, let's break down the extremes. The contrast is just wild.
Nice.
Start with Western Russia, this instant Arctic outbreak. How does the same system do that?
Well, because this dipole is so strong, so amplified, it basically carves out this deep channel, a direct path for cold Arctic air to plunge south.
So like opening a freezer door right onto Russia.
Pretty much. Look at Moscow. Around November 10th, the forecast shows a huge temperature drop.
How much?
Over 25 degrees Fahrenheit, that's 14 Celsius, in just 24 hours.
Wow.
And lows hitting 18 Fahrenheit, minus 8 Celsius.
Minus 8C. That's serious cold for Moscow in mid-November.
It is. And the warning level orange isn't just for the cold itself. The main danger is a flash freeze.
Flash freeze, meaning rain turning to ice instantly.
Exactly. Light rain is forecast, hitting surfaces already below freezing, turning immediately to ice. Think about roads, power lines.
Absolute chaos, severe gridlock, major stress on infrastructure. Okay.
Yeah, big problem.
So while one side of this dipole, the high pressure, is plunging Russia into this deep freeze, the other side, the low pressure, is doing the opposite for Western and Central Europe, dragging in moisture.
That's the other side of the conveyor belt. It sets up this deep, persistent flow from the southwest straight into Western and Central Europe.
Bringing rain.
A lot of rain, sustained heavy rainfall. Some areas could see over 100 millimeters, that's 4 inches, in just 4 or 5 days.
And what's feeding all that moisture?
This is key. That air is flowing over North Atlantic and Mediterranean waters that are, frankly, freakishly warm.
How warm?
Running about 1.5 to 3 degrees Celsius warmer than usual for this time of year.
So that warm water pumps more moisture into the air.
Loads more. It supercharges the system. That's what feeds this potential named storm run they mentioned. And for Bram, the main threat isn't wind.
It's flooding, catastrophic flooding potential.
Absolutely.
Okay, so extreme cold, extreme rain, but the report's highest alert, the red warning, is for the Caucasus region, a compound hazard. What starts that?
It actually starts with heat. Really shocking heat for November.
Heat, in the middle of all this.
Yeah. Baku, Azerbaijan, is forecast to hit an incredible 83 degrees Fahrenheit.
83, that's what, 28 Celsius?
28.3 C, yeah. That's more than 26 degrees Fahrenheit above the average for mid-November.
See, summer heat in late autumn.
It's like early September warmth showing up 2 months late.
Yeah.
Really anomalous.
But wait, the heat itself isn't the disaster, is it? It's a precursor.
Exactly right. It sets the stage. The real trigger, the thing that makes this a red warning, is the forecast for intense thunderstorms around November 14th.
Okay, thunderstorms.
But crucially, this intense rain isn't falling on just any ground. It's hitting high-altitude areas.
Right.
Terrain that's been seriously destabilized by long-term glacier melt.
How much melt are we talking?
The report mentions an average of 600 meters of glacier retreat over the last century in parts of that region.
600 meters? So the ground is already unstable?
Critically unstable, eroded, loose. So you dump intense convective rainfall onto that.
And you get...
Catastrophic flash floods, mud flows, debris flows. It's a terrible combination.
Is there a precedent for this?
Yes, the sources are very clear. They point directly to the fatal Chovy mudflow event in Georgia, August 2023.
Oh, I remember that. Devastating.
They see that as the direct, deadly analog for this specific vulnerability. That's the compound hazard. The heat, the melt, then the trigger rain.
So just to recap, we have an Arctic plunge in Russia, potential major flooding in Western Europe, and this extreme heat setting up a catastrophic mudflow risk in the Caucasus.
All happening simultaneously.
And all tied back to this one single, highly amplified dipole pattern. Incredible.
It really highlights something important for you, the listener. People sometimes think climate change just means steady warming everywhere.
Right, like winters just get milder overall.
But this shows it's more complex. It amplifies the variability. Climate change doesn't eliminate cold snaps.
It can make them sharper, faster, like this flash freeze.
Exactly. And when you get warm flows, like into Europe, they're loaded with more moisture because the oceans are warmer. That atmospheric pump we talked about, it gets stronger.
Creating deeper lows and stronger highs, side by side. More extremes at both ends.
Precisely. It's a perfect illustration of the difference between long-term climate trends, like generally warming winters, and these short-term, high-impact weather events driven by amplified patterns.
That's a really clear takeaway. It really shifts how you think about climate impacts.
Yeah.
Which leaves us with maybe a final, quite sobering thought for you to consider. If something seemingly slow and distant, like 600 meters of glacier melt over decades, can suddenly turn a single thunderstorm forecast into an immediate life-threatening red warning, a compound hazard, what does that imply? What could this kind of hidden vulnerability mean for other major mountain ranges around the world facing similar changes?